All right, this is when we're factoring when that a is not 1. So you want to make sure that the function equals 0. Check to see if there's any greatest common factors. Then what we do is we use the diamond box method, and then we apply the zero product property to solve it. So here's an example. So we've already been doing the diamond boxed when a equals 1. These examples now are when a does not equal 1. So we go through the same process. We set the equation equal to 0, which it already is set up, and then we identify the a, b, and c. Then we do our diamond setup. The top of the diamond is a times c, so 6 times 1 is 6. The bottom of the diamond is your b, which is 5. Now we're looking for factors of 6 that add to 5. So what two numbers multiply to 6? So positive 3, positive 2, when we add them together, 3 plus 2, we get 5. So those will be the sides of my diamond. Now we set up our box. So notice now the top left-hand corner is going to be your ax squared. The bottom right is going to be your constant. The sides of the diamond make up your other two terms with x. Now we have our 4 terms. We're ready to go ahead and take out the GCFs of each of the rows and columns. So the first row, the greatest common factor, GCF, is 2x. The GCF of the second row is positive 1. The GCF of the first column is 3x. The GCF of the next column is positive 1. Now what's outside the boxes are your two binomials. So 2x plus 1 times 3x plus 1. Now we're going to go ahead and apply our zero product property so we can find the zeros or the roots of the function. So I'm going to set 2x plus 1 equal to 0, and then 3x plus 1 equal to 0, and then we solve them for x. So subtract 1 from both sides, so we get 2x equals negative 1, and then we divide both sides by 2. Go to the second equation, subtract 1 from both sides, we get 3x equals negative 1, and then divide both sides by 3. So our two roots are negative 1/2 and negative 1/3. Here's another example. This one's a little bit more challenging because not in standard form. So we need to move these two terms to the left side. So we're going to go ahead and subtract. We get minus 48x plus 32 equals 0. We also have a greatest common factor with these 3 terms. So what we can do is we can take out a 2 from all of the terms. So we're left with 9x squared minus minus 24x plus 16. So when we factor, we only set up the diamond in box with what's left in that parentheses. So that's kind of messy. I'm just going to write it down here again. So we have 2 quantity 9x squared minus 24x plus 16 equal to 0. We've taken out the greatest common factor. So now we work with that quadratic. We identify the A, 9, the B, negative 24, and the C, which is 16. Then we set up the diamond. 8 times C, so 9 times 16 is 144. The bottom of the diamond, negative 24. So we're looking for what are the factors of 144 that add to negative 24. And those numbers are negative 12 and negative 12. So now we set up our box. The first term is 9x squared. The bottom right is our C, positive 16. The sides of the diamond with an x, negative 12x, negative 12x. Now we take out the greatest common factors of the rows and columns. So the first row, those two terms, the GCF, is 3x. The second row, the GCF could be a positive 4 or a negative 4. I'm going to take out a negative 4, and then we have to check it when we're done. Go to the first column. The GCF is 3x. Could be negative 3x, but when I multiply 3x and 3x, I get a positive 9x squared. GCF of that last column, negative 4. Now make sure you multiply the red terms together and see that you end up with what's inside the box, those 4 terms. All right, so now what's outside the boxes will be our 2 binomials. So we have 3x minus 4, 3x minus 4, and then remember we had that number 2 that was factored out, so put that out in front. Now we apply the zero product property. If I set 2 equal to 0, that won't produce a root. So then we set these factors equal to 0. Notice they're the same factor, so I'm just going to focus on one of them, so 3x minus 4. And I'm going to have a repeated root. I add 4 to both sides. 3x equals 4. And then divide both sides by 3. So x is 4/3. And then you just say that it is a repeated 0 because you'll get the same for both of them, both of those factors. Again, that 2 outside here does not have the variable x, so it's not going to produce a 0 there.